Hello, Dr. Rauscher here. All right, let's look at this problem. Which of the laws are illustrated? Mass conservation, definite composition, or multiple proportions? All right, so first we need to really know what each of these different laws are. The law of mass conservation basically states that the mass of a mixture of elements in before a reaction takes place should be the same as the mass of those elements after a reaction takes place. The law of definite composition states basically that the elements will form compounds when they react together, but that the ratio of the elements need to be whole number ratios. And then the law of multiple proportions states that in some instances, you can form different proportions of those elements together in the compounds. So let's look at these three different scenarios and try and figure out what's going on. Okay, so in A here, we see that we have 1, 2, 3 of these red balls, and then we have 1, 2, 3 of the diatomic molecules, right? So altogether we have 6 of these pink ones, or light pink, and then 3 of the darker pink or magenta colored elements. So, and then after the reaction takes place, we've formed 3 molecules, and in each molecule we have 1 of these and 2 of those. Okay, so here we have 1, 2, 3 of these, just like we did there, and then 2, 4, 6 of those, just like we did over there. So this definitely shows the law of mass conservation, because the number of elements before and the number of elements after are the same. But it also shows the law of definite composition, because we are forming a compound here that has a definite composition, right? Can't have 1.5 of these light colored ones with 1 of the dark colored ones. So there's definite composition here as well. In the second one, B here, we have 1, 2, 3, 4 of the dark colored ones. If we go over here just real quick, 1, 2, 3, 4 of those. I'm going to switch colors here. And so that means, and so the at least for that darker colored one, we have a mass conservation, but let's continue and figure this out. So when we have 2, 4, 6, and 8 of the light colored ones, here we have 1, 2, 3, 4, 5, 6, 7, 8. Okay, so and indeed, mass conservation has been shown in this case. Okay, because we have the same number on each side of each element. We can say that the definite composition is also here because we have 2 of these to 1 of these, and we also have 1 to 1. Okay, so we have these 2 different things, but they are always in whole numbers, which means we have definite composition. Because we have 2 different forms of these mixture of these compounds or these elements, we can also say then that we have multiple proportions. So all 3 laws have been demonstrated here. We have 1 left over, which is not a problem. It doesn't mean any of these things is untrue. It means that just that we had an extra diatomic molecule of this compound, of this element, and it wasn't used. That's just perfectly fine. Down here, just by looking at this, I can say that the multiple proportions is going to be something that we're looking at, right? We also can see that we have definite composition, because there's no half molecule or half element or anything like that in there. So both of those laws are being taken into account. Now, whether the mass conservation is there or not, we're going to have to check. So let's just look right here. We got 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5. Okay, so in terms of the darker colored element, the law of mass conservation takes place. So then here we go with 2, 4, 6, 8, 10, and 1, 2, 3, 4, 5. So unfortunately, the mass conservation was not shown in this case, right? So mass conservation, I'll put this one in red, was not upheld in this picture. All right, thank you guys.